Alright, good evening folks. Welcome to yet another video on vectors. Must thank all my viewers and subscribers. Alright, so let's start. So here we have a question. It says OP and OR are position vector with respect to origin. P is the 0.27 and PR is 4, -3. Write in the form of AB the vector OP and OR. So what we have here is OP. Now you notice that P is given as a coordinate. So the 2 is X value and the 7 is the Y value. Now we can write a coordinate as a position vector. Alright, and this is how we write a coordinate as a position vector. We write O to P and then write it as a column matrix 2, 7. Now the X value goes right there, and that is our Y value. Remember, if the X value can either go left or right, and the Y value can either go up or down. And if you go left, the number here is negative. If you go right, the number is positive. So clearly this is telling us that this vector is going to go 2 places to the right, and this top number here is plus, this bottom number is negative. So clearly this is going 7 places up. Alright, so this is the answer for the first part, OP. Let's look at OR now. Now clearly we're going to have to use the second information in the question to work out OR. As you can see, we can just look at PR and get OR just like that. Alright, what we're going to have to do is that we're going to write the vector equation for PR. Now PR is P to O and O to R. Alright, so I can give you a little illustration here. So let's say this is the vector P, this is the vector R. So if I want to go from P to R, I would have to go from P to O and O to R. So this is our vector equation. So PR is P to O, O to R. Now what you notice, OR comes up. So we want to make OR the subject of the formula. Let's go over here now. Let us say, because all of this look complicated, but let us look at this. We have P equals O plus R. Let us say I want to make R the subject of the formula. Alright, so I don't need O. So what I'm going to do, I'm going to subtract O on the right and also on the left. Now O from O will give us 0, leaving R. So R turns out to be P, take away O. Likewise over here, I want to make OR the subject. So I don't need PO. So what I'm going to do, I'm going to subtract PO on the right and PO on the left. Now PO take away PO will be 0. So OR is actually equal to PR take away PO. Alright, so now we know that now we have the equation. We're gonna plug them in. Alright, so now what is PR? Now PR was given at the first part of the question. The PR is 4, -3. So PR 4, -3. Now we just worked out what OP was. OP was 2, 7, but this wants us to find PO, which is the inverse of the vector OP. Now to find the inverse, all we seem to do is just to change the sign of the original vector. So the +2 + 7 becomes -2, -7. So these are two matrices, and when we subtract in matrix, we subtract them entry by entry. So this is going to be 4 take away 2, negative 3 take away 7. Now when signs are together, what do? We use the rules of multiplication and add. So this turns out to be 4 plus 2, which is also 6. This turns out to be negative 3 plus 7. Negative 3 plus 7 will give us 4. You almost have around $3. Go shop with $7, you're going to have $4 change. So this is the answer for OR. Let's move on to the next part of the question. Part 2. A point S has coordinates 14, negative 2. Question A. Find RS. Part B. Show that P, R, and S are collinear. Collinear means that all 3 points lie in the same straight line. Let's work out the first part of the question. It says find RS. Now, RS is R to O. Now, what is RO? No, we just worked out OR. So RO would have been the inverse. So RO would have been negative 6, negative 4 plus OS. What is OS? Now, S was given as a coordinate. So we can write S as a position vector, which is OS. And we have 14 at the top. So this is the X value. And the negative 2 would have been the Y value. Alright, and when we do the math, we get negative 6 plus 14, negative 4 plus minus 2. Let me go up here. So negative 6 plus 14 equals positive 8. These two signs are together, not true? So we have negative 4, negative 2. So we owe and we owe 6. So this, ladies and gentlemen, represents R to S, the vector. Alright, last part of the question. The last part of the question says that show that P, R, and S are collinear. So let me give you a little view of what's happening. I'm wondering if I can answer this question on my notepad. All right, so we have 3 points, right? This is R. Sorry, this is P. Let's say this is P, this is R, and this is S. So what this question is asking us to prove. All right, they're saying that these 3 points are on a straight line. Prove that they are actually on a straight line. How do we do that? What we need to do, we need to find PR if we don't have it already. And we need to find RS. And we need to prove that these two vectors are parallel. All right? So do we know what PR is? Yeah, man. PR was given at the top of the question. PR is 4, negative 3. So let me write that down. PR, P to R, is 4, negative 3. What about RS? Yes. We just worked it out. Not true. RS is what? 8, negative 6. 8, negative 6. Alright. So what we need to do, guys, is to prove that these two vectors are parallel. Now, if these two vectors are parallel, it means that they're also collinear. Question number 1. How do we prove that vectors are parallel? 2 methods. We can either find their gradients or we can find a scalar multiple of the other vector. Now, if we find the gradients, and the both have the same gradient, then the two vectors are parallel. And if they're parallel, then they're also collinear. So we're going to find their gradient. And the formula for gradient, so PR, the gradient is actually y divided by x. So remember, this is the x value, this is the y value of PR. So the y value would have been -3 over the x value, which is 4. So the gradient of PR is -3 over 4, or -0.75. So this represents the gradient of PR. Let's find the gradient. The gradient of RS. The gradient of RS would have been y over x, and the y would have been -6 over 8. What do you notice? When you reduce that fraction, you get -3 over 4. You actually get the same thing, -0.75. So what you notice, these two gradients are the same. All right. Now, since they have the same gradients, then they are parallel, hence collinear. All right, so both of them have the same gradients, hence they are parallel. Now, the other way of proving this is to show that one is a scalar multiple of the other. All right, now just by observation, you realize that if this is PR and this is RS, if you multiply PR by 2, you get RS. Look at this. 2 4 is 8. 2 times -3 is -6. All right, so we can say method number 2, 2 PR from observation is equal to 1 RS. So what you can say, since PR is a scalar multiple of the other vector, then the two vectors are parallel. And if they're parallel, then they are collinear. All right, so that's the end of this question. Thank you for watching.